All right, so let's take a look at SOH CAH TOA. SOH CAH TOA up here, what you see, is a mnemonic device that's very helpful for us in order to help us remember the different components that go together when creating trigonomic ratios. So within SOH CAH TOA here, we see the S that correlates with sine, the C for cosine, and the T for tangent. And then what follows each of those letters is either O, H, or A. So here's OH, AH, and OA. And these O, H's, and A's represent opposite, hypotenuse, and adjacent sides. So let's talk about those for just a minute. Let's talk about this term opposite. Opposite is just going to be whichever side is directly on the other side of the shape from the angle in question. So if we are looking here at angle A, that's this angle right here, the opposite side is going to be this side over here, and I'll just abbreviate with OPP. That is the opposite side. Okay, it's clear across the other side of the shape, and what you'll notice is that that side, BC, with the value of 3, does not touch angle A in any way. Okay, the next term I want to draw your attention to is hypotenuse. And hypotenuse represents the side that is opposite the right angle. So if angle C here is my right angle, the hypotenuse, and I'll abbreviate with HYP, is always the side opposite of that right angle. That gets us into our third term here, which is adjacent. And adjacent represents whatever side angle A is touching. I'll put ADJ. All right, that's not the hypotenuse. Well, you notice that angle A here, it touches two sides. One is the hypotenuse and one is the adjacent angle. Okay, so adjacent, right, this term right here, adjacent, represents whatever side is touching angle A, but is not the hypotenuse. The hypotenuse is always the side opposite the right angle, and the opposite side is always the side on the other side of the shape that is not touching the angle in question. So let's talk about what this looks like in terms of using opposite, adjacent, and hypotenuse for creating trigonomic ratios. So I'm going to come through here and I'm going to erase a couple things real fast, clear up our space. So let's look at how SOH CAH TOA here, right? SOH CAH TOA is being used. Again, S, C, and T represent sine, cosine, and tangent. Okay. Now, what we're going to look at is one angle specifically at a time. So you see here we're looking at sine of A, cosine of A, and tangent of A. So everything that we're doing right now is in regards to this angle right here, angle A. So I'm going to follow these helpful tips: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, right? Those three side terms that we just talked about to help us find out a trigonomic ratio comparing sides in regards to angle A. So let's start with sine here. Sine of A has you focus on the opposite, which is right here, over the hypotenuse. So I want the opposite's value, 3, over the hypotenuse value of 5. So that would look like this ratio right here, 3 to 5. So that would be the sine of angle A, the value of the opposite over the value of the hypotenuse. Okay, so let's look at cosine. Let's see how cosine changes or differs from sine. With cosine, let's change color here. I'm looking for the adjacent, which is this side right here, over the hypotenuse, right? Adjacent over hypotenuse. So if the value of the adjacent side is 4 and the value of the hypotenuse is 5, we have our trigonomic ratio for the cosine of angle A, which is just 4 over 5. So see how we are just taking the different sides in question here and comparing them based on our SOH CAH TOA rule, right? Here's a little farther breakdown. The tangent of angle A, so tangent tells us I'm starting here at TOA. And TOA, T, is followed with O over A, which represents opposite, this side right here, over adjacent. this side right here. And we see that here, right? Opposite over adjacent, TOA, TOA. So I'm going to take the value of the opposite side, 3, and put it over the value of the adjacent side, 4. So using SOH CAH TOA, we are actually told all the different trigonomic ratios right up here in our mnemonic device. Now, that was all sine, cosine, and tangent for angle A. But now things are going to change for us because let's actually shift off of angle A and let's look at angle B. So we are no longer interested in angle A. So that's not going to let me delete that. There we go. Now I'm interested in angle B, this angle right here. Now something changes when I switch my angles, because if you notice, this is still the hypotenuse, right? It is still the side directly opposite of my right angle. However, you notice that this side right here is no longer the opposite, and this side right here is no longer adjacent. Recall that opposite means on the direct other side of the shape, not touching the angle in question. So this is no longer the opposite. And adjacent means a side touching the angle that's not the hypotenuse. And right now, this is not in the correct spot either. So I actually need to change these, okay? And we'll write opposite now over here, and adjacent, ADJ, abbreviations, over here. Now my opposite, hypotenuse, and adjacent sides are in the correct position. So it's very determinate based on which angle you're looking at. When I was looking at angle A, this was the opposite. But now that I'm looking at angle B, it's the adjacent, okay? So again, opposite, always the side over the or opposite the right angle. Adjacent, always the side connected to your angle, that's not the hypotenuse. And opposite is always the shape, the line on the other side of the shape, not connected to the angle in question. Okay. Now that we have our triangles terms here reset up, we can go through SOH CAH TOA again using sine over opposite, or sorry, sine of B equals opposite over hypotenuse. So if we're looking at angle B here, the opposite over the hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse, so get rid of these arrows. Cosine being adjacent over hypotenuse, that's 3 over 5. Okay, and then that gets us into our final one, which is tangent, TOA, TOA, which is opposite over adjacent. So opposite over adjacent. So 4 over 3. Okay, so what you're going to notice with these is every time I change my angle, right, from angle A to angle B, hypotenuse will always stay the same because it's always the side opposite the right angle, but the opposite and adjacent sides will change. So you have to pay direct attention to which one you're looking for. But let's draw some connections here real fast. We still have a little bit of time. If I took a look at the sine of A, I found that to be 3 over 5, a trigonomic ratio of 3 over 5. But take a look how that compares to the cosine of B. The cosine of B is also the trigonomic ratio of 3 over 5. And you can see other similarities as well, right? You can see that the cosine of A is 4 over 5, which is the same as the sine of B, 4 over 5, okay? So what you notice here is the sine and cosine of one angle are effectively the same as the sine and cosine of another angle, just a different trig ratio, right? The sine of one angle is the cosine of another. The cosine of one angle is the sine of another. And then the final thing we can pull away from is that the tangent of one angle, okay, the tangent of angle A being 3/4 is the reciprocal of the tangent of angle B, 4/3.